So, hello everyone, welcome to the YouTube channel. So, you already know we have started the subject that is the software engineering, right? So, as you know already, we already have started the subject that is a software engineering. So, we have covered up the different software development phases. So, we are almost like covering up the all the phases of the software development life cycle. We have started with the phase number one, that is, we can say the communication, or we can say the planning, or we can say the requirement analysis. Then the second phase was about the modeling, like designing, software designing, that we have seen the this is we are starting. So yes, we have started with the communication, that is the phase number we have already discussed about the requirement engineering, communication, planning. The second phase that we have, that is the modeling. We have gone through the software designing, like we have seen the architecture design, component level design, user interface design, the different kind of designing we have seen, right? So then we have the next phase, that is the implementation and the coding. We have seen the how exactly the implementation work, coding standards that needs to be followed, variables name, method name, class name, and all this thing, and reusing the code as much as possible, coding standards. Then in the previous video we have seen about the testing, the how much important the testing is. Like without a testing, your product is will not completed. It's a really important phase of any software development life cycle. The proper test you have, the more bug free product you will deliver. So different kind of testing strategies we have seen into the previous video, right? Different types of testing: unit testing, integration testing, testing, performance testing, application testing, so security testing, regression testing, smoke testing. So this is the kind of different kind of testing we have seen into the previous video. Now today we are moving towards the next topic, the next chapter, that is a quality management, which includes the quality control as well as a quality assurance. So let's move towards this chapter. Let's move ahead. So what exactly the quality management is? So it is also called as a software quality assurance, that is SQA. Serves as an umbrella activity that is applied throughout the software process. So we already have seen the umbrella activities in the chapter number one, right? So these are nothing but serves as an umbrella activity that is applied throughout the software process. Involves doing the software development correctly versus doing it over again. So software quality management, like managing the quality, assuring the quality, it does mean uh, implementing the software properly so that we should not be able to do the repeated task again and again, or we can create a bug free product. Reduces the amount of rework, which results in a lower cost and the improved time to the market. So software quality is not only about the testing, it's about doing the right work, reusable work, and manage the work, so that we have to reduce the amount of rework, so that ultimately we can deliver a software in a quick time. Ultimately we will do the more work. Yes. So this is about the quality management. So this encompasses a software quality assurance processes, specify a quality assurance and the quality control task, effective software engineering practices, control of all software work products, a procedure to ensure a compliance with the software development standards, and the measurement reporting mechanism. So these are the all things we will see into the detail now, right? So now what exactly the quality? Yes. So it is defined as a characteristic of attribute of something. Yes. You will be like developing a software, how the software is working, how's the performance, how's the UI, is there any bugs in the software. This is nothing but a characteristic of attribute of the something, or of a software. Refers to the measurable characteristic that we can compare to the non-standards. There are certain limited number of standards. Let's say your software should not be stuck at the number of users are accepting. So this is nothing but the standard. It should have the smooth UI and the attractive UI. This is nothing but the standard. So it refers to the measurable characteristic that we can compare to the non-standards in the software. It involves such a measures as a cyclomatic complexity, cohesion, coupling, function points, source lines of code. So as we already have covered up the cohesion, the more functional level code it should have. The coupling, it should have the less coupling, less dependency between all the functions, right? So this is the kind of thing we can define the quality as, right? So apart from this, we can design the two kinds of quality are we can see quality of, so like when we are developing a software, we have the different phases of the software development life cycle. So managing the software, it's about to managing the whole development life cycle, obvious thing. So we can divide into the quality of design as well as the quality of the conformance, or we can say the implementation. So what exactly the quality of design? The quality of design is the characteristic that designers specify for an item, and this encompasses the requirements, specification, and the design of the system. So this includes the first two phases, the requirement engineering and the software design. So whatsoever the requirement you are capturing, it should be captured properly, it should be applied the proper requirement engineering processes, it should be well documented into our document, it should be properly verified with the client. So once you have the full proof quality requirement with you, the next phase would be much more easier, and you will require a very much less work in the next phases. Okay, the similar case will be applied to the software designing. Once you have the proper requirement, now it's the designing team task to define a proper design, a well proof design, so that the implementation will have the less bugs. So ultimately the testing time will be reduced, the work of the testers will be reduced, and we will have the more quality work at the end of at the less time. So this all things are connected with each other. If you are doing a one thing properly, the next time would always do the proper, right? And the second is the quality of conformance, or we can say the quality of implementation. Once we have the requirements ready with us, once we have the design of a system ready with us, means software modeling is ready, now it's time to come up with the implementation. So the degree to which the design specifications are followed during the manufacturing, this focuses how well the implementation follows the design and how well the resulting system meets the requirement. Ultimately, a proper requirement converted to the proper designing, and the proper designing properly followed will give you the quality code ultimately, and meeting the end requirement. So this is nothing but we can measure the quality of design as well as the quality of the conformation, right? Ultimately at the end we can define what exactly the user satisfaction is. User satisfaction is compliant product plus good quality plus delivery within the budget schedule. So this is a really important term, last term. If you are doing a very much good quality product, if you are doing a proper requirement gathering, quality requirements, if you are doing the quality, we can say the designing, you are doing a quality implementation, but ultimately if you are not able to deliver the product at a time, or if you are not in the budget, so ultimately it is of no use. So this is also the important, the delivery of the product within the budget and the time, or we can say the schedule, right? So now the next two terms comes into the picture, that is a quality control as well as the quality assurance. So let's see the one by one. What exactly quality control we can say? This involves a series of inspections, reviews, tests used throughout the software process. So like it's like controlling the software development. It includes a series of inspection, whether it is going properly or not, reviews, whatsoever the code is developed, the reviews of the code, and the tests used to throughout the software process. And this ensures that each work product meets the requirement placed on it. So whatsoever the task we are doing, if we are developing any software module, whether it is meeting the software requirement or not, includes a feedback loop to process that the created work product, yes, combines the measurement and the feedback in order to adjust the process when the product specifications are not met. So this is the kind of thing we can say the quality control. While in the case of quality assurance, consists of the set of auditing and the reporting functions that assesses the effectiveness and the completeness of the quality control activities. So this is a kind of thing, this will check whether the quality control activities are working properly or not. This is a kind of auditing, or we can say the functioning of the quality control. Quality control activities are properly followed or not. Provides a management personnel with the data that provides an insight into the quality of the products. So this is a kind of thing. A quality control, it's nothing but the kind of series of inspections, reviews, and the tests used throughout the software processes. While in the case of assurances, we can say the consists of the set of auditing and the reporting function that assesses the effectiveness and the completeness of the quality control activities. Now, what exactly the cost of the quality? The cost of the quality includes all the cost incurred in the pursuit of the quality or in the performing the quality related activities. Yes, the cost of the quality, where and whatsoever at particular location the quality measures are applied, is nothing but the cost of the quality. This applies to provide a baseline for the current cost quality, identify opportunities for reducing the cost of quality, and provide a normalized basis. See, let's say we are putting the tests, so this also include the cost of the quality. We are providing the team of validations. This also includes the cost of the quality. We are investing, let's say, some time to review the code. This is includes the cost of the quality. So ultimately these are nothing but we can say the cost of the quality, right? So in short we can say it takes a less time to do a thing right than to explain why you did it wrong, right? Yes. So this is the kind of thing. Now, uh, what are the different kinds of quality costs? If we are like asking about what could be the quality cost, there is a different kind of quality costs. First one is a prevention cost. This is nothing but a quality planning, formal technical reviews, test equipment, and the training. Yes, as I told you, if you are doing a review, you are investing a time. If you are doing a testing, you need a person to do the testing. So it is nothing but the uh, one type of cost you have to provide. Obviously you will be paying something to the testers, right? Then we have the appraisal clause cost, inspection, equipment calibration, and the maintenance testing. This is also one type of costing we have. Failure cost subdivided into the internal failure cost and the external failure cost. So what if the quality is not properly measured? If your product is not quality, then if it fails, now if it is fell from the internal failure incurred when an error is detected in a procure prior to shipment. Yes, uh, it will include the rework repair when the failure model analysis. External failure involves the defects found after the product has been shipped. So both are the different thing. If you found the error before the product is developed, so the cost will be much more lesser. Because but if you have delivered the product to the client, right, and you have the failure, obviously you will have the bigger you will have the more cost. You have to pay the so much so much thing, right? So this is a kind of the quality cost we can have. Now we have the software quality assurance. So how we can define the software quality? In the definition we can say the conformation to explicitly stated functional and the performance requirements, explicitly documented development standards, and the implicit characteristics that are expected all of professionally developed software of. So rather than following a whole line, we can say a properly documented requirement, a properly followed approach, ultimately a properly tested product. We can say a software quality, right? In the short. Now, a more detail we can say a software quality defined the software. So what it should the software quality focuses on, the first focus on the software requirements are the foundation from which the quality is measured. So you should capture the requirement proper. You have to apply the proper and requirement engineering processes to identify the process to identify the proper software requirements. Then we have the specified standards defined a set of development criteria that guide the manner with the software is engineered. So you have to set some of the criteria in which you have to define some of the criteria in which manner you will be like identifying the software, you will be developing the software. We have the software quality is no longer the sole responsibility of a programmer. So we cannot say it is the only responsibility of a programmer. We have so many of software development phases. We have the different phases. So if we want to develop a foolproof software quality product, the each and every phase should be a quality output. It should produce a quality output, whether we are talking about the requirement engineering, or we are talking about the software modeling, if we are talking about the implementation, or if we are talking about the testing. Each and every phase should have a proper output, a quality output. So ultimately, at the end of the day, your software will be a quality product or the quality software. Yes. So we cannot say it's only responsibility of the programmer to develop a quality code. It's the responsibility of the whole team, a requirement engineering team, we can say a more software designing team, a programmers team, as well as the testers team, as well as the support team, or we can say the maintenance team. This all combined with together, we can say it will produce us quality software, and that is needed from the market, right? Now we can say the software quality assurance group serves as a customer's in-house representative, assists the software team in achieving high quality product, views the software from the customer's point of view, performs a set of activities. Now there are SQA groups, whether in the bigger projects, bigger companies, the software quality assurance are have some people in the group from the customer side, which will help the uh, team, the development team, to identify so that the software should be quality product. Helps to the in the requirements, helps in the verifying the requirements, verifying the product, and helps the each and every like validating the product at each and every phase, so that the each end product should be a quality product. Now, what should be the SQA activities, software quality assurance activities? First of all, prepares an SQA plan for the project, participate in the development of the project software process description, then reviews, then audits, ensures that the deviation in the software work and the work products are documented, records any non-compliance and the reports to the senior management, and the coordinate the control and the management chain. First of all, the first need should be the preparing the SQA plan, software quality assurance plan, then participating in the we can say the development of the project software process description in the requirement description, then the in the review process, code review process, requirement review process, then we have the audits design that designate the software work products to verify the compliance with those defined as a part of the software process, ensures that if any deviation in the product, if any deviation in the requirement, it should be properly documented, then records and non-compliance and the reports to the senior management. If any non-compliance, or if any change, or if any dispute, it should be reported to the senior management, right? Then we have the software reviews. This is kind of nothing but a part of, we can say, so what we are looking at, we are looking at the software quality management, in which the first we have the software quality assurance that we have already seen, the SQA. Then we have the software, then we have the reviews. Reviews are very much important in the software quality management. So the purpose of reviews serves as a filter of a software process, are applied at a various points during the software processes, uncover the errors that can be removed, purify the software analysis, design, coding, and the testing activities. So reviews, not only the coding side, the review should be at each and every phase: analysis phase, design phase, coding phase, and the testing phase. Once you complete the analysis phase, once you have the design, you should have a reviews on that. Then on the design, you should have the review on that. Once you have the coding, you should have the review on that. Once you have the testing, you have the review on that, right? So after the review, you will find what you are missing, what exactly you are missing, and you can identify that and you can work on that, right? So what exactly this include? This include the formal technical review, shortly told term as a FTR, formal technical reviews. Okay, so let's move into the detail what exactly the FTR is, formal technical review. The formal technical review is kind of, we can say, the one type of review after the task is completed. Yes. What exactly the formal technical reviews? The objectives of that: to uncover the errors in the functions, logic, or implementation of any representative of the software, to verify that the software under review meets its requirement, just the FTR of the requirements, FTR of the code, to ensure that the software has been represented according to the preferred standards, it's following the proper standards, to achieve the software that is developed in the uniform manner, and to make the projects more manageable. So it serves as a training ground for junior software engineers to observe different approaches to software analysis, design, and the construction. So this is more applicable to the junior engineers, for what? For their training, because they are very much less experienced, so they should be their code, their implementation, their everything should be properly reviewed. Promotes backup and the continuity, because a number of people become familiar with the other parts of the software. May sometimes be a simple review, right? Then what exactly the FTR meeting will have? So it will have from 3 to 5 people should be included, Advanced preparation like reading should occur for the each participant but should require no more than 2 hours apiece. So what exactly, like let's say a junior engineer is working on a particular software module. He has developed the module. So what exactly the FTR will include? There the 3 to 5 people will, the senior people and all the people come together. They will have the PowerPoint presentation, or we can say the projector meeting. So the whatsoever the code is developed by the junior engineer, it should be represented to the senior members. So senior member will identify whether the particular junior engineer is following the proper guidance or not, whether he is working properly or not, the code is working properly or not, coding standards are proper or not, whether we are going according to the requirement or not. If they have changed, they will guide them to change it or not, so that the junior engineers will have the experience on that. So these are the very much important terms. So this focuses on the specific work product, a software requirement specification, a detailed design, and the source code listing. So what should be, so this is the kind of thing the FTR meeting will have, right? This is a kind of thing the FTR meeting will have. Now, so there are the different stages of the FTR meeting. Before the meeting, what should do? On the meeting, what should be concluded, and after the meeting, what should the conclusion of the meeting? So before the meeting, the producer informs the project manager that the work product is complete and ready for review, right? The project manager contacts a review leader who evaluates the product for a readiness, generates copies of the product materials, and distribute them to the reviewers. Each reviewer spends a 1 or 2 hours reviewing the product and making a notes before actual reviewing meeting. The review leader establishes an agenda for review meeting and schedule a time and location. So what happens? Let's say a junior engineer has developed a particular module, right? So it will so junior engineer develop a particular module. He will inform the project manager that my module is ready and ready for the review. The project manager contacts the review leader, send him a copy of a code, so and he will spend a couple of hours or the couple of hours to read the code. Once the code is read, he will inform the team members and the particular junior engineer to come into the meeting at the particular conference room or a meeting room. Then the FTR meeting will be done. So this is a kind of thing the before the meeting that should be happen. Then after, on the FTR meeting, the meeting is attended by the review leader, all the reviewers, and the producer. One of the reviewer also serves as a recorder for all the issues. After the brief introduction by the review leader, the producer proceeds to walk through the work product while reviewers ask the question and raise the issue. The recorder notes any valid parameter. So this is a kind of thing the internal discussion works on the particular product, particular module that is developed by the junior engineer. If any points there, they should be discussed, they should be carried out, and if any updates to that, they should be recorded onto the particular point. Then we have the activities at the conclusion of the meeting, that is all the attendees must decide whether to accept the product without a further modification, yes, whether the product is completely acceptable, reject, it's completely not acceptable, yes, accepted but on some updation, and that update should be captured and given to the particular producer who has developed the particular module. So this is nothing but the before the meeting, on the meeting, and the after the meeting conclusion of that FTR meeting. The FTR stands for the formal technical reviews, right? So the FTR meeting is a very much important team, so this should be carried out by the very much well defined companies. Now what are the FTR guidelines? Review the product, set an agenda, limit the debate and the rebuttal, so don't waste too much of time because we have so much to work to do. Take written notes, yes, of course. Limit the number of participants, don't combine, we don't have the chat room, we are just here for discussion. Develop a checklist for each product, provide a checklist, what should be updated on that and what should be approved and what should be rejected. Allocate a resource and schedule time for FTRs, yes. Conduct a meaningful training for all the reviewers and review your earlier reviews to improve the overall review process. So this is a kind of thing that should be taken care into the FTR guidelines, right? Now the next topic we have, that is a statistical software quality assurance. So this will include the collect and categorizing the information about the software defects that occur, attempt to trace each defect to underlying causes, and using the Petrio principle, 80% of the defects can be traced to the 20% of all the causes, right? So these are the sample possible causes for the defects, that is an incomplete or the erroneous specification, misinterpretation of the customer communication, Intentional deviation from the specification. So first of all, what should be the reason for the failure? The first should be the requirements are not proper, the communication with the client is not proper, uh, change from the requirement, not following the proper programming standards, error in the data, inconsistent component, errors in the logic, incomplete testing, inaccurate documentation, errors in the programming language, and ambiguous or we can say the confusive human interface or a computer interface. So this is the kind of thing that can lead to the defects into the product or defects into the software, right? So for that we have the Six Sigma. So this is nothing but the popularized by the Motorola in the 1980s. Is the most widely used strategy for the statistical quality assurance. It is most for the statistical quality assurance, uses data and statistical analysis to measure and improve the company's over operational performance. So it uses a data to measure and improve the company's operational performance, identifies and eliminates defects in the manufacturing and the service related processes. The Six Sigma refers to the six standard deviation, right? So what exactly the Six Sigma is? So these are the define the customer requirements, deliverables, and the project goal via well-defined methods of customer communication. Then measure the existing process and its output to determine current quality performance. Analyze the defects matrix and determine the vital few causes. So first of all, define the customer requirements. What should be the customer need, and what is the project and what exactly the project goal. Measures the existing processing and output, yes, and analyze the defect. So this is the core steps. Then the two additional steps are added for existing process, that is improve the process by eliminating the root cause of defect, yes, control the process to ensure that the future work does not reintroduce the causes of the defect. First of all, if you have any defect into a product, find out the root cause, of that. Don't be sometime what happens, like when you are like testing that, you will be saying like it is working in the Google Chrome but it is not working in the Mozilla Firefox. See, this is not the problem, right? The problem is a different, you are saying that it is working in the one place and it is not working on the another place. So this is not the root cause of any problem, the root causes are different. So identify the root problem of the defect, and once you get the defect is solved. So take care that that defect should not be repeated again, right? So this is the kind of thing, all of these steps need to be performed so that you can manage the process to accomplish something. You cannot effectively manage and improve the process until you first do the three steps. So first of all, identify the work to be done, define the work process, measure the work process, analyze the work process, control the work process, and manage and improve the work process. This is nothing but the Six Sigma principle. Identify the work to be done, measure the process, analyze the process, control the work process, and manage and improve the work process. So this is a kind of thing, the Six Sigma. Yes. Then we have the software reliability, availability, and the safety. So reliability is nothing but it whether your software is reliable or not. How can you say that whether your software is reliable or not? So first of all, what actually the software failure is? It's not properly following the requirement. It's not like part of the requirements. So this is software failure. Then we have the software reliability, define the probability of the failure free operation of the software application. It's, we can say, the failure free. The software is working correctly on your requirement without any failure. That's nothing but the software reliability. A simple measure which we can have the different type of equation, we are not going into that. Then we have the software availability. The probability of the software application is operating according to the requirement at a given point of time. Yes, your software is working properly at any given time of time. That is nothing but the availability of your software reliability, right? And software safety focuses on the identification and assessment of the potential hazard of the software operation. It differs from the software reliability. Software reliability uses a statistical analysis to determine the likelihood. Software safety examines the ways in which the failure result in the condition that can lead to the hazard, right? So software safety is kind of thing, it identifies what are the reasons that fail, that that causes a failures, and we are being safe from that particular, we are preventing that failures. This is nothing but the software safety. Okay, so this is a kind of thing that will differ. So this was all about, right? Yes, so finally the final point is that we have the software quality assurance plan that will have, provides the roadmap for instituting the software quality, developed by the SQA group to serve as a template for XUA. So what should have the purpose and the scope of the plan, a description of the all software engineering work, all applicable standards, SQA actions and the tasks, the tools and the methods, and the final have the methods for assembling, safeguarding, and the maintaining all the SQA related records, and the finally it will have the organizational rules, responsibilities related to the product quality. So this will have the software quality assurance plan. So this was all about the software quality assurance, or we can say the software quality management. So thank you very much all. Thank you very much for watching our video. Have a great day.